Hello, I'm making a video about the performance of Windows console. Okay, so last time someone is making some this, yeah, he Molly Rocket, right? He made this refterm, I think. Right? Yeah, just the guy saying, "Oh, it's very bad," right? Oh, you get a setters, and he's making very good videos, and he's a game dev. Okay, but you know, I have a library called fastio, which is I actually got banned for the last time of my library, but now I have a new library. I just created the library. So I have a library that's called fastio that is around 10 times faster than Iostream. But I haven't, just this benchmark is extremely old, and I want to see what if we use fastio altogether with the refterm exporting here. So what I did is that I created a makefile. Of course, we can use both GCC and client, but I'm just using client right now. Of course, we can test GCC too, but yeah, let's just first test that. Let's test GCC. Okay. So I use this precompiled header file, so we can generate these precompiled header files, and the precompile will be fast. Oh, there's one problem, is that GCC on Windows does not correctly support GCH. Okay. It has some bugs with the precompiled headers on Windows, and I even put the patch file. I think it's still bad. It's just not test. That's why I'm not going to test GCC right now. But here what we can do is we try to do this. Okay, something like this. So we print from 0 to 10 million. Not 10 million, just a million. Okay, not too large, just a million, because you cannot just output 10 million. So we're going to test how long it takes to output to the standard I/O. Okay, this is with using GCC. Okay, we are using GCC, which is, if we go to client's target, we know it's Windows GNU. It's not actually MSVC. So we are using GNU's torch, not actually using the MSVC torch. So what I'm doing is that I'm going to build the file here. Okay. So I want to see how long it takes just to run stdio. Let's just first run in CMD, okay? And we run stdio. And after the file, if the file is running out, and it will output to this stdio.txt file, and we can see how long it takes. We can see it is extremely slow, right? It's extremely slow. Every set, I think probably going to take. I think it's probably going to take just three minutes just to finish this out. What we are just doing is just output from 0 to a million, or okay, right? But it takes a huge amount of time. Still waiting. This is ridiculous. Okay, guys, this is ridiculous. This is folks. Okay, I'm sure it's the guys. Okay, you also maybe some of my audience are not boys, but whatever. So you can see it takes so much time. Okay. Probably, I think you can just jump the video to a minute later. It's a huge amount of time. Okay. Sorry. I actually don't want to test this yet, but I think there's something. Despite I love the video, I think there's something he did. What he said is wrong with this results play, whatever. So, okay. I think we can use the time to explain other file. Okay, what the other file is doing. So, I'm testing both the stdio and Iostream. Iostream is not MSVC's Iostream is GCC's Iostream. Okay, GCC Iostream. And the binary size is around 20 kilobytes, and the only thing large you can see is any large is stdio, not actually anything else. But here we have an stdio hack, which is if you're using FastIO's print function, it has the stdio on your platform. So we're going to test how long it takes just to hack your platform, okay? But it takes a huge amount of time. So this is to hack stdio. So this is that we just directly create a buffer on top of Win32 get stdout handle to see how long it takes just to directly output to stdout. Just directly output to stdout handle. Okay, just directly calling Win32 APIs. And this is the F pipe, which is the fast pipe. Okay, I actually provide a driver just for dealing with the refterm terminal. So let me see. In this prefix, you have a refterm. You can see, you can actually see that in the not in here. It's just in cleanup. Okay, I actually try to clean up things and put everything here. So it's actually a refterm just to deal with the fast pipe. And since if you watch the video made by him, he created a fast pipe, right? So we can see whether fast pipe will work with the stuff. Okay, stdout is finally out. We can see how long it takes. It takes 200 seconds. Okay, 200 seconds, which is 3 minutes. 3 minutes 20 seconds. Okay, so let's just put here. stdio plus cmd takes 200 some seconds. Okay. You might wonder why I have such a large precision. Okay. Guess what? Okay, I just directly calling Win32 whatever APIs, whatever. So it gives me a very high precision just to measure something. Compared to if you're using the chrono whatever nonsense. Okay, don't use C++ chrono, it's horribly bad. And let's just see what about hack, stdio by stdio hack. Okay, let's just see if you're using FastIO's println, how long it will take. Okay, I think I don't want to test Iostream because I think we can test Iostream for example. Let's see what how long Iostream will take. But I think probably also take a huge amount of time. Probably a little bit faster than stdio because the stdio on Windows is pretty bad. I think it's because of the maybe W64 they add something to the MSVCRT. Since MSVCRT is extremely old, they have to put some functionalities just to make it faster, right? Not make it faster, just to make it satisfy the standard, the ISOC and ISOC++ standard. Then it takes a huge amount of time. So let's see what's going to happen if we're using Iostream. This Iostream just will still output 10 minutes. Okay, I think I should put the minimum function, but I don't even need to put in Iostream header, right? Okay, because I actually put in the precompiled header file. There's no reason to put in the compiled header file. Yeah, I think I should just modify it and upload to my Github, my repository. Yeah, just the functionalities are same, but it should work this way. So I think this is faster. We can see it's much faster than the stdio here on GCC. Of course, if you're using the MSVC, it takes a huge amount of time just to output things from Iostream. Let's see how long it takes for Iostream. It takes 96 seconds, which is Iostream plus CMD takes 96 seconds. Now what about FastIO's stdio hack? This stdio hack, okay, which means I only use stdio. We reuse stdio functionalities, just you reuse the buffer. and it takes me 7 seconds. Take me 7 seconds. So if we're just directly running buffer with ourselves, we don't actually using anything. All we can do is, okay, here we can claim is that something is because they have the buffer here, but in fact it's much more complicated than that. Because here you have the synchronization, have all sorts of things here. Let's see what if we are just directly using Iostream. You might say, how can we use Iostream? Well, you cannot directly do this. What I did is that I hacked the C++ Iostream, and we just directly construct Iostream from Win32 handle to a FD, then to a Firestar. So what you see is that we directly construct an Iostream from MT syscall. So we use the MT syscall to construct an Iostream. Okay, we construct a fireabove file, and fireabove file we move our fireabove files to fireabove to the Iostream. Let's see how long this one takes. Okay, it takes us 6 seconds. Okay. So which is just directly, which means we have no CRLF, which is complete LLF, which is directly coding NT syscall plus C++ F3 on libstdc, not on MSVC. Okay, if we are using MSVC, we get different results. Okay, we get completely different results. It'll be very slow. But on libc2c++ actually have fixed a lot of bugs with libc2c++. So libc2c++ is actually pretty fast compared to other C++ standard library. Particularly, libc is a horrible mess. libc is a horrible mess. So if we're just directly coding this guy, it takes us that kind of seconds. So if we just we're not using the Iostream on Iostream, but we use Iostream's fireabove. We just use fireabove, but we just fastIO's hack on stdio's fireabove. So which means I hacked the stdio's fireabove. Okay, so this is fireabove file. We just directly output that stuff instead of using construct Iostream. We just directly output that. Let's see how long this guy takes. Okay. It should be much faster. I think it should be faster. Maybe I'm wrong. Okay, it takes 7 seconds. Okay, looks like it doesn't improve anything. Okay, whatever. So what if we just directly using the output file, right? We just directly output things and we don't add any buffer. We just directly output the standard out. How long this guy takes? Takes the same time because now the time is wasting on the syscall itself. 4 seconds. Okay, it's just this one is much faster. It takes 4 seconds. Which is we directly output to add a buffer and a buffer and output to stdout. Okay, output to stdout handle. Okay, so let's just view the result here. So if you're using Iostream on Windows, it actually takes 20 times slower than Iostream plus CMD. Then you have the stdio, which is this guy. This part is the CMD part. Okay, CMD result. Okay, this is CMD result. We have this. Now, okay, what we also have is that he have a fast pipe, right? But we don't have fast pipe. We are not running the refterm. So let's just start to running refterm to see how long that kind of takes. Now first, let's just test stdio. Okay, we just still delete all this exe file because maybe create a file will add some syscall overhead here. So let's just directly delete it. But also we can just enable fast pipe. we have the fast pipe option. We can enable fast pipe. So let's just first run stdio. Okay, just immediately down. Okay, so it takes 1 second. stdio plus refterm takes 1 second. Okay. Let's just try Iostream plus cmd. I'll talk about refterm. So how long Iostream will take? Okay, Iostream takes us. Iostream. Okay, I should say this. This is on GNU libstdc++, not on msvc or not lib C++ or vmzip C++. So it takes us 0.0 seconds, 0.9 seconds. Okay. 0.09 seconds. V2, okay, V2. Now let's just continue test the third guy, right? The third guy is fast IO's hack on stdio Firestar. How long that would guys take? So we just call stdio hack. Okay, stdio hack. So it takes us 0.03 seconds. Okay, 0.363 seconds. Plus refterm v2. So let's just continue test mtsyscall plus fstream plus flibc++. Okay, I think it should be, maybe it'll be faster, maybe it'll be slower. Let's just see whether that goes on here. Oh, it takes a little bit slower than the fast IO stuff, which is they're pretty close. But you know, the fast IO's hack on stdio, this guy is actually thread safe. Okay, but if you're using the Iostream stuff, this guy is not thread safe. Okay, so it's not actually not thread safe. It only works on if you're in a local variable, it's a single thread stuff. Okay, so this guy has some locking overhead, but you can see even at locking overhead, fast IO is still running with thread safe mode, which is faster than libc++ and as whatever, you know, refterm, which is faster, a little bit faster. Let's just continue to test this guy. Okay, the next guy, which is fast IO's hack on Iostream, which is this hack on stdio. This guy is hacked on Iostream. So we just include firebar fire. Okay, it looks like it's much faster. So, oh no. Oh, okay. I see. So this guy is just on CMD. They're all on CMD. This is on the Fstream. Okay. So next, let's just take what if I just add a buffer on the stuff. Just directly add a buffer and just directly output the plus refterm v2. So we use. So which guy? It should be the above guy. Above this yeah, this one. Okay, so it takes us pretty close to the Iostream, right? Just because they are using basically the same functionality based on fast IO's logic. They are using exactly basically the same routine, so you can see it's reasonable that they are pretty close. But we know that guy, he added a refterm, means that he have the fast pipe, right? We know he has a fast pipe on and fast pipe out. So if we enable fast pipe, it will create a secret channel with it. And I can actually have a driver, a fast IO driver, just to use the fast pipe. Okay, let's see the fast pipe here. Okay, so we have you can directly create the fast pipe with fast IO. So let's just see what about F pipe. 0.04 second, okay, which is buffer, okay, just buffer plus refterm v2, which takes us 0.1 second. So let's just make a comparison between these results. So how long? So first, if you're just using fast IO, you get 50 times improve. 50 times. Well, let's just calculate it, which is 41 times improvement. Okay, 41 improvements on just by using fast IO. Using fast IO. Okay. Now this if we just for CMD case, okay. But for the refterm case, I just compare together. If we're using the refterm, using whatever, if you're using the refterm v2 plus this is fast type. So it takes us. Let's just see how long this guy. Just make a symbol. Let's cut it. Okay. 200 times. 200 to 400. So this, if you compare to this, is 206, 207 times improvement faster than stdio in refterm v2. Now, if you're using fast type, it is. I don't think our calculator can calculate this. Just too many precisions here. So it gives us 300 times faster. Okay. Than stdio in refterm. But we can also make a great comparison between the largest result we have here in the compared to this one, right? Fast type plus refterm versus stdio versus CMD. So let's make a comparison versus them. So which means stdio takes how long? How much time? So we do a division, right? We divide this stuff. Divide by. Okay, which is 40. What the fuck? Okay. Maybe you can run it again. Maybe we can get a larger result, because it is actually not stable. Maybe we run again and we get a better result. Okay, can we see if we can run a better result with fast type? I actually feel that it's actually become slower, you know. Whatever. Okay, they just that case. Not much changes. So whatever. So it is 40 kilo. Okay, 4. Okay. Okay. So just faster. Okay. Let's just cut it. What the fuck? What the fuck? Okay. Fuck you, Microsoft, right? 47. Think how bad it is. Which means our CPU. Okay, let's just see our CPU. Okay. My CPU is 40. Just take this for base. It is 3.6 gigahertz. Okay. If you divide by this, which means our CPU only runs, I think it's around 98. So think how bad today is, right? Okay. And so if you're using fast IO, even you don't use fast pipe, you get 200. You get 30. I think 30 46,000 times. This is 46,548 times. Okay, which is basically, you can see if you're running slow, you can just take 50 kilobytes. I actually, last time I run in the refterm v1, I actually get the result. I get 50 kilobytes, okay, 50k times faster. Okay, 50 times, 50k kilo times faster, with 50,000 times faster. Wow, 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 wow. So fast.io plus refterm is 50 kilo times faster than stdio plus CMD. Okay. This, if you think I'm just cheating, I just saved 46 seconds. Whatever. So it's okay. That's, you know, they just, everyone just see that result, just completely rage about it, right? I think it's probably other. Oh, I remember there's other cost here. I will show here. So we did not flush the buffer. We didn't do anything else. While the fast type case is actually using that stuff. Okay. Whatever, using alt buff, whatever, they all close handle. That takes time. So whatever. So that's it. Okay. That's all about the video, and hope you enjoy it. And yeah. So yeah. So done. Okay, done. Okay, how to close it?